Okay, so we're talking today about multiples, and that's dealing with LCM and LCD. You guys hopefully have already been exposed to least common multiple. And so here's your definition of what least common multiple is. It's the least, and then here goes, non-zero multiple that is common to all of the numbers. So if someone wants to ask me, what's the definition of a least common multiple? It's the least common multiple. Do you guys get the word least? Yes. I hope you do. Common, I hope you get it better, even as we talked about it yesterday. But you really need to know multiple. Is multiple the same thing as factor? No. If it was, we wouldn't have two lessons separating the two. We'd have only one. So we're going to talk about multiples. Yes, sir. Did you want to add something or what? Okay, that's all right. All right. Does anyone know what a multiple is then before we move on? What's a multiple? Okay, a factor, this review, is a number that goes into a number, another number. So like, what's a factor of 10? 5. 1, 2, 10, right? Okay, but that's not the same as a multiple. So what's a multiple? Okay, Alex?
It says it right here.
Oh, gives you, wait, no way. Oh, go ahead and read that for me.
A multiple of a number is the product of that number and any equal number.
Okay, and people are probably thinking, okay, great, what is that? It's in that yellow box on the top of page 8. Remember, a multiple is a number. And maybe you're thinking, okay, that's the definition. That really didn't help. So what we're going to do here is we're going to look at an actual problem of finding the LCM. Oh, don't want that. Actually, does anyone need this previous screen? Is everyone good on that? Because I'm going to erase it. Okay, so what we're going to do is we're going to work out a problem, and we're going to use two methods. Sometimes the first method is good, sometimes the second method is good, and unfortunately, guys, it's not using that upside down division. I know a lot of you liked it, but we're not using it on this method on multiples because we're dealing with something else. Okay, if not, you can copy it from someone else. Sorry. Okay, here we have a problem to find the least common multiple, the LCM. We're going to use our first method, and that'll help us to know what multiples even are. So this first method is listing all the multiples, which I will tell you is a hard task to do. Multiples. So listing all the multiples, which when you see my list, you're going to realize, wait, Mr. A, you didn't even list them all. Oh, that's not good. Okay, let's look at two numbers, 4 and 6. I want to find the least common multiple of 4 and 6. Okay? That's what I'm trying to look for. If you can get in your head, great. If you have a question, okay. Okay, this is what we need to get, guys. What are the multiples of 4? The first multiple of 4 is 0. It's 0. And you're like, how'd you get that? What's 4 times 0? That's my first multiple. All right, my second one is 4 times 1. What's 4 times 1? 4. What's the next one? Well, what's 4 times 2? 8. You guys get a pattern here?
Oh, shoot, brother.
Dot, dot, dot. Why do I put dot, dot, dot?
I did that wrong. Because it keeps going into
Yeah, how many multiples of a number are there?
Oh, yeah, it's just infinite.
Infinite. I can't list them out, so I'm going to put my dots so I can.
Adding that up, right?
You just keep adding 4 to the previous multiple. Yeah. And
Keep listing them out until you find the LCM.
yeah. That's method number 1. Yep. And I'll underline this is method 1. Method 1 works for a lot of problems, but not all of them. Oh my, not all of them. Okay. What's the first multiple of 6? 0. Because what's 6 times 0? That's your first multiple. All right. Next one. 6, 12, 18, 24, and just going to go dot, dot, dot. Okay. By the way, if you use method number 1 on these problems, like this one, it's not that bad. Actually, it's actually very easy. On another problem, if we want to do method 1, we'll be here for a while, and we might not even get it. which would be sad, right? You work a long time and don't get the problem right. So method 1 is good for numbers that have a small least common multiple, but not always the case. Okay, what are the common multiples of 4 and 6? And notice I said, what are the common multiples? What are the common multiples? Yep, Anna Grace?
0 and 12.
0 and 12. And how many are there, by the way? Common multiples. 2 up here. How many exist? Oh, man. Infinite.
Well, there's another one, but...
Oh, if I kept going, those would be common, right? And then how many would they have in common? Infinite number. That's why I don't want all the common multiples. I want the least common multiple. But, Mr. A, what is that? It's 0, isn't it? Isn't 0 the least common? Well, yes. The definition said it's not the least, it's not the first common multiple, because what's the first common multiple of any numbers? So that's not helpful. That doesn't help me at all. But the first non-zero multiple would be 12. So the LCM, and I'll write this down, of 4 and 6 is 12. That's my least common multiple. I just want to write that down so you get in your head what we're saying. Brad, did you have a question?
I was just going to say, if you kept going, with like 4, would it always have 2 in between each LCM, or each common multiple?
That's actually a good question. So like if I had 28, 32, let's just see that. That's a great question. And then the next one would be 36, right? And then this one would be 30, 36. And so here...
Every other for the 6 and then every 2.
So you guys see a pattern there? So that's good, Brad. So every 2, and then here every other, which is really cool. Okay, you guys see a pattern? Okay, but do I have to know them all? Please don't tell me them all. I don't know what they all are. I do know there's a pattern, but I do know that the smallest non-zero multiple is 12. Okay, you guys kind of get that method? Yep. And you can do this in your head too. You don't have to list them out, but if you can find out, okay, what's that, then do it. But I'm telling you, some of these you can't. Sorry, Drew.
You said this method doesn't work for all of them. Why would you teach it to us then?
Because you need to know it for smaller numbers. Like smaller numbers, I would do this method. The other method, I would use it for those bigger numbers. Yeah, I want to give you tools. It's kind of like, let me give you an example here, guys. I am not a handyman at all. My dad, he is a handyman. Like, he tried to teach me stuff. I just never listened. So in my toolbox, when I was first married, I have one little toolbox. And I needed a hammer. So I look at my toolbox, no hammer. Of course, I don't have a hammer. Why wouldn't I have a hammer? So, instead of a hammer, I used, I don't remember what it was, maybe a screwdriver and a wrench, heavy wrench, put a paper towel, like a rag, and started using it as a hammer. Now it worked, right? It worked. It did the job. But was that the most efficient or effective way to do that job? To put something down, like a nail, with a wrench and a rag? No. What was the best tool to use? The hammer. So could I do it with the wrench and the rag? I did it, guys. But what's way better? The hammer. So I'm giving you tools. Sometimes the hammer works, sometimes the wrench works, just depending on the job. Yes, sir?
Can I get some water real quick?
Yes, sir. And now, Swivel, I just revealed my lack of handy-manness. Okay, sorry.
So you want to use this for like small numbers, like how small?
What a great question. How about this? I'm going to ask on different problems which ones you would use, and you'll be able to tell method 2 is way better. Method 1, I could do method 1, Mr. A, and then this person, no, I need method 2. It just depends. It really does. It's more subjective.
You think method 1's easier?
No. It's good on this one, really, but it's not the easiest. No. Okay, yes, sir.
So you want to use method 1 on the smaller numbers and then method 2 on the bigger numbers?
That's general.
What if you had,
I'm listening. Go ahead.
numbers that were big numbers, but you could find the LCM like really fast?
Yeah, then use your memory. Maybe that's method 3. Use what you know. And that happens. So I'm going to teach 2 methods, but we'll talk about some others. Okay, Yes, I saw another hand. Anybody? Is that it? Okay. Use prime. Close. Factorization. I have a question here, guys, with prime factorization because the other class, they were having a little bit of a hard time. Raise your hand and don't be, listen, if I ever ask a question about whether you know or don't know something, don't be afraid to say I don't know something. I was with you in that when I was younger. I didn't always get stuff. I'm like, don't have a clue what you're talking about, teacher. But we grow from it. So let me ask you this question. Prime factorization, the factor tree. Does anyone not know what I'm doing there? The factor tree? Come on, give me that hand. I don't care. It's not going to hurt my feelings, okay? Because then that helps me know when I explain it, I'm going to be a little bit clearer to not confuse you. Don't feel bad. If someone was telling me like number theory, that's college level stuff like number theory, I'm going to ask them a question. Wait, what are you saying there, teacher? Because I don't get it. And if I let the teacher know, the teacher's going to help me out like, okay, I'm going to walk you through this a little bit slower. Hopefully they'll help me out. Okay, same two numbers, and you're going to see why we didn't use this method, but we could use the method. I'm not saying you can't. Okay, prime factorization. When I'm trying to get the prime factorization of a set of numbers, what I'm doing, one method to do that is use that factor tree. And you're like, factor tree? This is what I'm asking. Can you give me a multiplication fact that gets me 4 other than 1 times 4? Because that doesn't help. Yes, Mary? 2 times 2. And some people like writing a little multiplication symbol so they know you're multiplying 2 times 2 to get 4. That makes sense? Okay, now I ask, are 2, or I guess is 2 or 2, same number, are they prime numbers?
Yes.
Prime numbers? You guys agree with that? So I circle it, and I don't have to branch out anymore. I'm done. I'm done with the prime factorization. Okay, well, let's do it with 6. Give me a multiplication fact with 6. Yep.
2 times 3.
2 times 3. Okay. Are either one of these prime numbers?
2.
And 3. So we're done with that one. Thankfully, this is nice. Nice and small. You guys got to kind of get that? If you need to put this little symbol here to tell me that that's multiplying, fine. I'm okay. All right. This method it's really, I've taught this now. This is my 8th time teaching it. Well, no, it's probably like my 12th time teaching it because I teach it. Wow, no, it can't be. It's got to be like my 20th time because I teach it to 6th grade, 7th grade, 8th grade, 9th grade, and I've done that for several years. And it's still hard to explain. Please stay with me, okay? Ask questions when you don't get it, and maybe Mr. A might have to change the way he says it. Can we work together here? I got your attention at least, so let's see what I'm talking about. Okay, prime factorization of 4. So I'm just going to list them out. 2 times 2. So it's going to put 2 times 2. Okay, and the prime factorization of 6 is 2 times 3. Any questions on that? I'm just showing what's 4 in prime factorization. 2 times 2, 6, 2 times 3. Yes, ma'am?
Okay, so if there were like more numbers, and would you like just put a comma and write blank times blank, or would you just keep doing blank times blank times blank?
Oh, no, you just keep putting 2 times 2 times 2 times 2 times 3 times 3 times 5 times, just times symbols. Don't put those commas. Yeah, good question. All right. Okay, here we go. And I'm right now I'm asking the Lord, please give them wisdom, help me to have the words. What I'm asking for now to find that LCM using method number 2, and again, method 1 is better, but you can do method 2, is I'm asking how many unique factors are in this set of prime factorizations. Unique factors. Do you know what the word unique means? It means special or one of a kind. Okay, so how many one of a kind numbers are there? Philip?
3.
Close. So just looking at these, so 2, 2, 2, and 3. How many one-of-a-kind numbers are there? So I know what you're thinking, Philip, but one-of-a-kind numbers. 2. The 2 unique numbers are 2 and 3.
What do you mean?
What do you mean? I thought it was 4, 6, and 3.
Okay, it's not that. Just these numbers. Just the prime factorizations. How many unique factors are there? And we would say So ignore this right now. How many unique factors are there? There's a 2 and a 3. Those are unique. You guys okay with that? If you can get that concept, we're gonna roll with this, kind of, because the second half is still a little bit tough. Hudson?
So how do you get the LCM out of book?
Yeah, let me finish. I'm not done yet. Yeah, that's a good question. I just want to get that unique concept, and then I'm going to get the second concept, put them together.
So would the unique concept always be the prime numbers at the end?
It's dealing with the prime numbers at the end. You got to get those prime numbers, then we can get that unique idea. Yes, ma'am?
So are the unique numbers the numbers that are just there?
Yeah, the ones being multiplied. So 2, 2, 2, 3. There are 2 unique numbers, 2 and 3. And I gave this illustration. All right, ready, guys? In this room, there are, I think, 4 colors of shirts or tops. There's blue, red, green, white, and gray. So 5. Is that what I said? You guys see blue, red, green, white, and gray. 5, right? That colors. I'm just talking about colors, not types of shirts. Okay, how many people are wearing red? Raise your hand. Okay, several of you. Blue?
I'm wearing all 3.
Blue? Sorry, reds, put your hands down. White? Gray? Or green? Okay, so here's my question. How many unique colors are in here? How many unique colors are in here? 5. Right? There's 22 of you if you're all here. Yep. But there's 5 unique colors. Is that okay to say? 5 unique colors? So how many numbers are here in the prime factorization? 4. How many unique numbers are there? 2. Oh, praise the Lord, He's giving you. Okay, you get that? We're good. For now. Okay, so getting my prime factorization, I got this right here. There are 2 unique numbers, 2 and 3. Okay? Now this is the second part where if you guys get it, it doesn't come from me because this is like my 21st time or 20, I don't even know. I've done this too many times. I have to look at each unique factor. So I got to look at 2 and 3. And I have to ask myself, how many times is it used in either one of these factorizations? So this is one factorization, second factorization. Okay with that? So how many times is 2 used in the first factorization? Twice. How many times is 2 used in the second factorization? Once. So then I ask this final question. I'm almost done. How many times is 2 used the most in either one of these? Twice. So I'm going to use it twice. Ooh. Man. Oh, man. Okay. And I'm going to do this over and over again till you're like, okay. Yeah.
I remember.
That's okay. Remember, I asked the Lord, give us humility, give us that patience, because sometimes we don't get it the first time. It's okay. You don't all have to get it the first time. Okay, how many times is 3 used in the first prime factorization? Sorry, in the first prime, none. How many times is it used in the second one? Once. So I'm going to use it 1 time, which I don't have to write that, but I'm just going to put that. Okay, ready? What's 2 to the second? 3 to the first? I just multiply those out. That's my least common multiple.
Oh my gosh. How did we
I
get
get that.
Yes. I get that.
Sorry. Questions. Give me a question. Like, what did you do here? Why'd you do there? What'd you do there? Why'd you do this? Okay, go ahead.
I get the end, like where we do
This?
where we started at LCM equals.
Okay.
But I don't get anything before that.
This?
Yeah.
Okay. We're going to do this. We're going to do this a lot. This is good. That's okay. Just practice. Yes, ma'am?
Okay, so the unique numbers, is that just the different numbers that are being used?
Yes.
It doesn't have like anything else to do with it, just like the numbers are being used.
Just think of it that way. You'll be safe. Yep. There's.
How many is it?
It's an emergency. Yep. Same.
Why are you 4 times 3? Where'd you get the 4?
Yeah. What's 2 to the second power? That means 2 times 2, which is 4. And then 3 to the first power just means 3. Finally, last step, multiply them out.
But then if you add all the 3 2's up, you can get 6.
Okay, so you said add them all up, which would give you 6, but what's happening between them?
But if you did 2 times 2, which is 4, and then 4 times 2, which is
8, and then 8 times 3, which is 24. You do get a common multiple. It's 24. Is that a common multiple between these two? Yep. But is it the least common multiple? Yeah, in a sense. But yeah, do it like that. Because these are small numbers. I'm going to give you big numbers. Okay, yeah, Drew?
For like the small numbers, can we do them in our head?
Yeah. Some of them you just do it right in your head, boom. So what's the least common multiple, for example? Least common multiple of 4 and 2. 4 and 2. It's 4. And some of you are like, yeah.
What do you mean, brother?
Sorry, just make sure we have that respect for one another and how we talk. You know what I mean?
Yeah.
Okay, so we're going to go through that many times. So if you don't get it, it's okay. All right, let's do this problem. On page 9, number 1. Page 9, very bottom, it says, try these, do number 1. I'll do it with you. So number 1, find the least common multiple of 6 and 24. Some of you can do in your head. Some of you, so bottom page 9, at the very bottom it says, try these, number 1. You guys see that? Where it says 6 and 24. Okay, some of you can do it quickly, great. Some of you, it takes you a little bit of time, fine. And some of you, it'll take you a little bit longer. That's okay. It happens. Okay, which method would you use here? Method 1 or method 2?
1.
Okay, how many of you use method 1 where you just list them out? You could do it in your head or you could just actually write them. Okay, how many of you use method 2, prime factorization? Okay, how many of you just know it? Okay, great. You have different varieties. I'll get to one where you can't do it in your head. I can't do it in my head. I'm going to be stuck there for a while. Nope, lost the number. Okay, but anyway, let's go through method 1, and then I'll go through method 2, and then hopefully you all got it. Okay, method 1 is listing all the multiples. So what are the multiples of 6? 0, and I don't want to confuse you guys. I'll just do it the same way I did. What are the multiples of 6? 0, 6, 12. Can you help me out?
18.
Okay, and then what are the multiples of 24? 0, 24, 48, 72, 90. Okay, you're like, I couldn't have gotten those, but thankfully, what's a common multiple? Okay, and is that the least common multiple that's not 0? Yeah, because both of them have 0, but 24. So the answer is 24. Okay, so how many of you got 24? Whether you use this method or another method. Okay, either method, any, you just knew it. Okay, now we're going to do it method number 2. So does anyone still need this? You guys get what I did here? I would use method 1 is nice on this one, or you just knew it. That's fine. But I got to go through method 2 so you can get it for the next example I'll give to you, which it's tough. Okay, what's the prime factorization of 6? There's 3 and 2. So 3 times 2, they're both prime numbers. I'm done with them. Okay, prime factorization of 24. Andrew?
6 and 4.
So I'll go 6 and 4. Neither of them are prime. So what's 6 break down into? 3 times 2. Both of those are prime. 4, 2, and 2. Both of those are prime. I need a question if you have it here, because if you can't do this, we're stuck. Ma'am?
So, I did it to start out with 12 and 2. Would it turn out the same way?
You got 12 and 2. You circled your 2. Mm-hmm. You got 6 and 2?
Yes.
You circled another 2. 3 and 2? Yes. Circled another 2 and the 3. You got 3 2s and a 3.
Okay.
So you should get the same number. That's what's cool about it. You can do any numbers. Yep.
So you take the 2 3's and this 3 to the second power? No, first power. So it's just, 3 to the second power.
Sorry? Oh, are you trying to do the next step?
Yeah.
Okay, hold on. Sorry, Sam. Just hold on. No, you're thinking. I know you're thinking about it well, but let's.
How are you doing that?
Do you get this part? Okay. Do you get this part?
Yes.
Okay. Let's hold off. Now let's move to the next step. Okay. Are you guys okay with this? Anyone else have a question? Or forever hold your peace. If you don't get this, you need to raise your hand.
How did you get 24? Did you just...
Those are the 2 numbers they gave me.
Oh, okay.
Yeah. This is in the problem. Okay. All right. So here, 6 is going to be 2 times 3. And 24 is going to be 2 times 2 times 2 times 3. So I just listed them out, least to greatest. Any questions on that? That's like an intermediate step.
Do you have to do it from least to greatest?
It's easier to see. You don't have to, but it's easier to use. Okay, we're good on that? Whew. How many unique factors, how many unique prime numbers are there? Unique prime numbers. Everyone give me your fingers. This many. What are the two numbers? 2 and 3. You are correct. So here's how, if I know that the two unique factors are 2 and 3, I know that my LCM is going to have the number 2 and the number 3, but now I'm going to find out how many times I'm going to use them. Should I use 2 once, twice, 3 times, 4 times? I don't know. This is what you have to ask. How many times is 2 used in the first number? Once. In the second number? 3 times. So how many times is it used the most? 3 or 1?
3.
So 2 to the third power. That's mean.
I added them up and did 4.
Yeah, don't add them up. No. Good. That's good because people are going to do that. So don't add them up. Just do 2 times 2 times 2, which is 2 to the third, right? 2 to the third. How many times is 3 used the most in any one of these? So how many is it used here, Alex? Once. How many here, Sam? Once. So how many times is it used the most? Andrew? Once. So 3 to the first, which you don't have to write 1, but you can. Now you multiply those two together. What's 2 to the third again? 8. What's 3 to the first? 3. What's 8 times 3? 24. Is that what we got? Oh, look at that. It is scary, but soon it'll be that it's my problem here. When I had that wrench and that rag, there were some jobs that I was doing where I was hitting, I don't know specifically, I was starting to hit something that could get damaged if I hit it with the actual wrench. So I just said, you know what, I just need to go buy a hammer. Because I don't do that, I don't go buy tools. I got that hammer, it worked. So far, method 2 has not been very nice. This next problem, method 2 is going to be your best friend. It's going to be the hammer when you need it. Yes, ma'am.
Okay, so I feel like I got 6 instead of 8.
Because you did 2 times 3,
Yeah.
but it's really 2.
3 times 2.
Yeah, 3 times. Yep. Good. Okay, let's do the next one. How many of you are okay with that? Like, you can follow me. Maybe you can't do it on your own yet, but you can follow me. Like, okay, I know what you did. Okay, now we'll do another one. Maybe you'll get to that point where you can do it on your own. Okay, this next problem is actually number, on the bottom of page 9, it's number 3. What are those numbers? Sorry, I don't think I have them. 9, 15, and 24? Oh. Okay, method number 1. What would you have to do here? Method 1. List out the multiples. 9, 18, 27, okay, 36, so on and so forth. Okay, I'm going to save you some trouble. It's way out there. Way out there. I'm not using method 1. You'll see when we get the answer. Method 1 was not the best. Okay, so let's go with method 2. All right, Michelle. 9 breaks down into what prime numbers? 3 and 3. So that one's done. Help me out with the factor tree, Sam, for 15.
5 and 3.
5 and 3. Again, you could do 3 and 5. It doesn't matter with the order there. And then 24, Matthew.
6 and 4.
All right, we'll go 6 and 4. Can you do 12 and 2, Mr. A? Of course, but we'll go 6 and 4. 3 and 8. Okay, Matthew, keep going. 3 and 2 for the 6. And then 2 and 2. Oh, that looks familiar. Wait, we've done this before. You know, when you keep doing these problems, you're going to see some numbers that are the same. And some of you, this is kind of cool, you're going to memorize the prime factorization of 24. You're just going to know 2 times 2 times 2 times 3, just because you do it so much. Okay, you guys okay with my prime factorization?
The light just turned on.
Oh.
I understand it.
Okay. Let's follow me here, and let's keep going here. All right, I'm going to work over here so I have a little more space. What's the prime factorization of 9? 3 times 3. What's the prime factorization of 15? I'll raise this up a bit. 3 times 5. What's the prime factorization of 24? Well, hopefully you've seen this before. 2 times 2 times 2 times 3. A lot of numbers. Okay, I'm going to call on someone here. I'm going to do it. Natalie, how many unique factors, how many unique prime factors are there?
3.
3 of them. What are the unique factors, Hagen?
3, 5, and 2.
3, 5, and 2, or 2, 3, and 5. Okay, I'm going to use for my LCM 2, 3, and 5. I've got to use them at least once. Okay, Jackson, how many times is 2? I'm going to ask you 3 questions. How many times is 2 used as a factor here?
2 is 3 times.
Sorry, 2 is used in this factor?
0.
0. Here?
0.
Here? 3 times. How many times should I use it then? 3 times. Because it's used the most 3 times. You guys get that? Okay. Jack, how many times is 3 used here? 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 How many times should I use it? 2 times. I'll put a little 2 here. 5. Mary? Shh. Quiet. Mary, how many times is 5 used here? None time? Or no, none time?
None times.
No amount of times? Here? Once? So how many times should I use it? Once. So I'll just put a 1 here. And then we're going to multiply these values. And you're like, okay, what is it? Okay, there. Listen, if you're getting it, it's good, but we're losing a little order, and some people are still not getting it yet. Darius, what's 2 to the 3rd power? 8. Eva, what's 3 to the 2nd power? 9. And we should know that 5 to the 1st is just 5. What's 8 times 9 times 5?
360.
Okay, here we get 72 times 5 is 360. That's the LCM. Okay, I'm going to go back in time. Remember method 1? Okay, think about it. 9. Let's zoom all the way to 81. 90, 99, 108. I don't like this. Okay, fine. But what about 15? 15, 30, 45, 60, 75. I don't like that one either. 24, 48, 72, 96. Please don't make me do this anymore. You got a third of the way there when you got to that point. For that number, which method is superior in this case? Method number 2. This is good. Guys, I'm proud of you for paying attention, for asking questions, and it's okay if you don't get it. Like, if I expect every one of you to get it at the first try, I'm being foolish. Like, I don't even think that, but little by little we'll get it. I'm going to give you a practice problem. You're going to do it all by yourself.
I understand it now.
12, 16, and 18. Find the LCM of 12, 16, and 18. All 3 of those, the LCM. So use your method. Choose your destiny on that one. And don't give the answer out. Don't say it, because some people are still working through it while you're done, and you don't want to give them an unfair advantage because they want to get it on their own eventually, I hope. My heart right now is doing this. I'm rooting for you guys. I want you guys to get it right. If you don't, it's okay. But if you do, I'll be happy. Probably more happy than you are. Because this is not an easy concept. And this is only my 20th time teaching it. So I should be better at it. Oh, thank you, Lord. He's good. He's good. You guys got it because He gave it to you, not me. Okay. I'm working behind you. That means I'm working at a slower pace. I hope you got your prime factorization of these numbers. And then you're starting to look at unique prime numbers and how many times you should use them when you finally multiply. So, all right, I'm going to ask different people. You may be selected, you may not. Hudson, what's the prime factorization of 12? Sorry, 2 times 2 times 3. Good. 2 times 2 times 3. I hope you got that. Gracie, did you get the prime factorization of 16?
Yeah, it was 2 times 2 times 2.
Good. 2 times 2 times 2 times 2. Also known as 2 to the 4th. Yes, ma'am.
Okay, I got 2 times 4 times 2.
Okay, 4 fits, but can 4 be broken down more?
Yeah.
So break it down to 2 and 2. All right, 18. Josiah, what's prime factorization of 18? All right, 2 times 3 times 3. All right, we're good with that. Prime factorizations. How many of you got those prime factorizations either the first time or at least you get it now? Like, okay, yeah. Okay. Henry, how many times should I use 2?
4 times.
4 times. Brad, how many times should I use 3?
1. Wait, 2.
2 times. Drew, what other numbers should I use? Okay. What's 2 to the 4th? William.
16.
What's 3 to the 2nd? Andrew.
3 to the 2nd, 9.
9. 16 times 9, Jackson. Jack? 144, which is your LCM. Okay, can you raise your hand if you got it? And keep it up because I need to do an inventory. It's okay if you didn't. I just want to see.
I didn't finish.
Okay, that's all right. If you didn't finish, it's okay. How many of you, if I gave you a little more time, you would have gotten it? You're just like a little bit behind. Okay, that's just as good. How many of you think you get it? Okay. I'm not a baseball player. I know, Drew, you do baseball, right? Who else plays baseball? Hudson. All right. Guys, I don't know how to throw a curveball, but I imagine it's difficult. I'm not going to do it because I'm embarrassing myself. Okay, I'm going to throw you a curveball mathematically. Okay, last problem we're going to do. And I want to see if you guys can apply what we've done already. Okay, I want you to find the LCM, not of just numbers, but of algebraic expressions. Okay, go ahead and gasp. Let it out. All right, 35x squared and 175xy. You're like, uh-oh, Mr. A, I got the numbers, but the letters. Okay, listen to me, guys. I'm going to ask questions. I'll wait. The other class got it, but I don't know about you guys. Okay, when you're looking at this expression, you might be thinking, oh, man, Mr. A, the numbers I was starting to get, and then why are you going to throw me x squared? Okay, does anyone know what x... Well, let me give you a more broad question. Does anyone know what a variable stands for? Raise your hand. Sam?
1.
It can stand for 1.
X and Y stand for 1 because it doesn't give you a space.
Okay, I think you have some understanding there that I'm going to use. I'm going to tell you I don't know. I do not know what it stands for. But what does it stand for, even if you don't know exactly what it stands for? I'm trying to get to this. Mary? It stands for some number. I just do not know it. You guys okay with that? This is unknown. I don't know it. It's X. And what does Y stand for?
A random number.
Some other number, right? That's not necessarily X, but can be. Okay. So you're like, okay, fine. Why did you go through that? I'm going to do the prime factorization of both expressions, and you're going to find out I get distracted too. I'm going to show you that it's the same exact process we did with the other problems. All right, so how about this? Does anyone know what the prime factorization of just 35 is? Just 35.
7 times 5.
7 times 5. So they're both prime. So do you know what the prime factorization of 35x squared is? Here it is. Ready? It's 5 times 7 times x times x. What? What does x squared mean? X times x. Okay, fine. All right, 175 is a little tougher. Anyone want to help me with that one? What goes into 175? 25, how many times? I think I heard someone say it. 7 times. If you didn't know that, I would just divide it by 5 and then see what I get. All right, I got 7. And then here, what's 25? 5 and 5. Sorry, I had to put, don't put this in your notes. This will confuse you. Dot, dot, dot. To be continued. Time is up. There is no homework tonight, but listen carefully. Tomorrow we're going to finish this out. We're going to work it through. This is happening a lot more than I want, but it happens. Have a good day.